11.1, today we are dealing with measures of central tendency. Okay, measures of central tendency. Measures of center, and actually measures of variation as well. Okay, so page 330, I want you to look through those vocab terms and tell your neighbor which ones you know. All right, here we go, 11.1. Which of these do you know? How many know what measure of center is? How many know what mean is?
Yes.
Mean, another word, average. Okay? Generally, that's the term we use. Okay? How about median? That is the middle number. That's when the data is in order from least to greatest or greatest to least. I'm going to put least to greatest. That doesn't matter. It could be least to greatest or greatest to least. Okay? How about mode? Good. The one that occurs the most often. Okay, the most common number. Very good. The most often. That is the mode. I remember it because mean is tough. It's mean to make you do it. It takes the longest. Mode, M-O, and M-O. And then median is the last one. Median is like the thing in the middle of the freeway, by the way. It's called the median. We had a conversation first period. You should not drive in the median when you're driving. They frown on that. Okay? Outlier. What's an outlier?
One that's not in like the, what's the one thing? It's like the line of best fit or something like that. It's like outside of the.
Good. Yeah?
It's
Okay. Hey, you guys, when you think of a line of best fit, that's a good way to think about it. Pay attention. It's the one that stands out from the rest. It's the one that is not clumped around the rest. It is the one that, that kind of breaks the trend. That's a good way to think about it. Okay? So, it is one that does not, lie with the rest. It is the outlier. It's away from the rest of the data. Okay? Measure of variation. You guys will be able to put a example there later. Measure of variation. Okay? You'll have to get that later. Range. Good. Largest minus smallest is your range. Largest hashtag minus the smallest hashtag. Okay? Standard deviation. Some of you did that earlier today with me, but it's hard to put in words, that's for sure. No. It's going to be kind of a mess.
Deviation is like when you do something you're not supposed to. Right?
Yeah, not being deviant. Okay? But it's deviating from the mean.
Like dividing.
Okay, we'll come back to it. Data transformation.
Is it like on the graph?
It's when we move data. We'll get to that as well. Okay, so some things we need to cover. Well, if you look at the next page, it actually defines mean, median, and mode. And please note that this right here is a symbol for mean. It represents the mean, X bar there. You're going to want to know that symbol. Jason, you're going to want to know that symbol. Okay? Logan already knows it. That's why he's talking to you. He's trying to keep you from knowing it. That's ridiculous. Come on, Logan. Don't be that guy. All right? Median is the middle number. We obviously know that. We abbreviate it MED. And then mode. Okay? Standard deviation. That's kind of the new one. That is the actual formula for standard deviation.
That looks fun.
Yeah, it's a hoot. Okay? The standard deviation of a numerical set number or data set is the measure of how much a typical value differs, or typical value in the data set differs from the mean. The symbol sigma represents the standard deviation. It is read as sigma. This is the lowercase value for sigma. Okay? It is a Greek letter. Okay? Yep, that is. Hey, you want to know this symbol.
Oh,
You need to know that symbol.
What's the symbol?
No, we're not going to go there right now. Okay? Where n is the number of values, n equals the number of values, underline that. The deviation of the data value x is the difference in the data values of the mean of the data x and x bar. X minus x bar. The steps, you find the mean, you find the deviation, you square the deviation, you find the mean of the squared deviations, which we call the variance, and then we take the square root of the variance. All of that being said, this becomes a mess to find. So when we go through one of these, I'll kind of walk you through it in a nice fashion, and then I'll explain how to do it in an easier fashion as well. Okay? All right. Let's turn to the next page. Some transformations. Important information that you'll reference back to. We'll just touch on it briefly. When a real number, which we'll call k, is added to each numerical value, the measures of center can be found by just adding k to that. So if a measure of center, the measures of center are mean, median, and mode. Those are your measures of center. So if you're adding 5 to each data value, then you're just increasing those by 5. The measures of variation don't change. The measures of variation are your range and your standard deviation. Measures of variation. They will not change if you add a value. And then lastly, when each numeric value in a data set is multiplied by k, if k is bigger than 1, the measures of center and variation both change by multiplying by that value. Okay, so I just presented everything that we're going to cover in this lesson. Okay, these are your notes, and hopefully most of this comes back and you can reference it and you can make notes on it later, and when you come back to it, you're like, okay, that makes a little more sense once we go through some of these. So, example or problem number 1. Consider this data. Find the mean, median, and mode. Okay? You're not allowed to use a calculator right now. Okay? Mean, median, mode. Hey, can I walk you through the first one so I can show you guys how quick it can be? When you're finding the mean, median, mode, the first thing I would do is take the data and I'd put it in numerical order. So I'd say the lowest number is 2, and then plus another 2, plus another 2, plus a 3, plus a 4, plus a 4, plus a 5, and plus a 16. Oops, I missed a 7. Plus a 7, and plus a 16. Now by crossing them out as I do it, it makes it so I don't forget one. So I quickly looked up and looked at 16 and said it, but then I recognized there's a 7 as well. I double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equals 9. There are 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. I did not forget a number. They are in numerical order so that when I calculate the median, it's easy to find. The sum is 2 plus 2 plus 2 plus 3 plus 4 plus 4 plus 5 plus 7 plus 16, or is what? 45. Okay? She used her brain calculator. Nice job. Okay?
Where can I get one of those?
It's in your head. Just saying. All right. So that is the sum. And then from there, we take and 45 divided by 9, which is 5. That is our mean. Okay? Remember, mean we call x bar. The median, since they're already in numeric order, just start taking one off each end. There's a 2, 16, 2, 7, 2, 5, 3, 4. The median is 4. The mode, they're in order. It's easy to find. It is 2. Now, just so you know, you could have a situation where there is no mode at all. Nothing occurs more than once, so there's no mode. Or you could have a situation where you have 2 or 3 modes. You have multiple numbers appearing multiple times. Maybe you'd have another 4 in here. You'd have a 2 and 4. Okay? Your median, you could have a situation where you have 2 middle numbers, where you'd have to, like if 3 and 4 were both, there was nothing else to cross out, you'd have to add them up and divide by 2. That would be the median then. Okay? Which measure of center represents the data the best? Explain. Tell your neighbor what you think and why. How many say mean? How many say median? How many say mode? You got to vote for one. Come on, pick one.
Mean.
How many say mean? I said it too fast. You like a cat like Steve, man. How many said mean? Median. Mode. Okay, so most of you said median. Why median? Bailey? Doesn't factor in the outlier. Very good. The mean does. So the mean actually is above the data set, right? Like when the data is in order, the mean appears up here because that outlier is pulling it up. The mode actually appears way down here. The median is in the middle. So the mean is greater than most of the data, and the mode is less than most of the data. Okay, that's why I would choose the median. And as Bailey said, the mean's greater because it's affected by the outlier. The outlier of 16. So there's a good example of an outlier there. Okay. So once you look at 2, what do you guys think? Go ahead and identify the outlier there. Tell your neighbor how it's going to affect the mean, median, and mode. Okay, which one's the outlier?
44.
Yes, 44 is our outlier. Does it affect the mean?
Yes.
Does it affect the median? Yeah, it's going to affect the mean and the median by pulling it. It's going to decrease the mean and the median. Now, it's going to decrease the mean because we find the sum. Okay, and that's a small number. And it's going to increase the median or decrease the median because that's a number. As we put these things in order, that is a number that is on the lower end. Okay? Will it affect the mode? No, it does not affect the mode. I'm not going to write all that out there. Why? At what? Actually, I have it written out. I'll put it here. What's one possible explanation for the outlier? Yeah? Yeah, maybe it's a baby gorilla. Okay? You're dealing with masses of gorillas. Maybe you're dealing with a baby gorilla there. Okay? Could have quite a few different answers, but what's that? Okay, page 333. Here we go. Take a look at the data there. Find the range for each team, then compare.
No, 54. Oh no, this is 40. I'm so dumb.
Dealing with range here, right? So you got your minimum and your maximum. 48 and 78. So 78 minus 48 is what?
She's not amused.
What?
Oh, Jason called Kellen dumb, and she was not amused.
No, I didn't. No, I didn't. No, I never said that. I was like, wait.
You
Be
never
done. Hold on. Be done talking. Okay. Let's be done. Okay. Minimum minus or maximum minus minimum. So 30 inches. That's our range in heights there. That's a pretty decent range. You think about. I think you guys up here were talking about in terms of feet. That's like 1.5 feet. Or excuse me, 2.5 feet. Right?
That's real tall.
Yeah. Like what's 78 inches? Yeah, it doesn't mean that it's like someone's 2.5 foot tall. Okay? 78 inches, 78 divided by 12, how tall is that? You can use your calculators now if you have to. 78 divided by 12. Huh? 6.5 feet. 48 divided by 12. 4 feet, that's a short person, man.
That's a short person.
But it doesn't say what age team there. Okay? Maybe it's a younger age team. Minimum here. Yeah, then you'd have some tall kids
70.
also.
You get 21.
Good. 70 minus 49 is 21 inches. Our range there is 21. The range of Team A is, if we're comparing them, the range of Team A is greater. Yeah. There's our comparison. All right. Okay, we are going to find the standard deviation on number 4 using the data from Team A. Now, in order to find the standard deviation, what I'm going to show you how to do is use your graphing calculator for it, because I'm not going to make you do that long calculation. So you need a graphing calculator. Okay, we've got Team A up there. You guys, I'll tell you this the first time. I am going to tell you how to use this calculator. And then if you don't write down the notes for it and reference them, I am not going to tell you how to do it again. So you'll have to go back and watch the online video or find it online. Okay? So take good notes right now. Those of you that want to try to memorize it, good luck. There are a lot of steps. If you don't believe me, ask Gunner. A lot of steps. Tons of steps. Okay? And I'm going to actually show, those of you who have already heard this from me, I'm actually going to show one other step, and it's how to clear your memory. And a lot of you have already done this with the graphing calculator, but it's second plus 7, 1, 2. That's on the TA83 and 84. Second plus 7, 1, 2. So on your notes somewhere, clear memory. These are the keystrokes. Second plus 7, 1, 2. That is the code. Think of it as a code right there. If you want to read what it all means, then go back and do that later. But it should say memory cleared and you're good to go. Okay? From there, the next step in putting this into your graphing calculator is you need to push stat. So the stat key is right here. Okay? So, stat, right here, means statistics. And then you need to select option 1, which is edit. And then in that list, you are going to enter your data. Now the reason I don't have anything in my list 1 is because I just cleared the memory. If you don't clear your memory each time, you're going to have something there in list 1. Okay, for instance, if I have those numbers in list 1 and I want to clear them, you could just scroll up to where it says L1. Can you guys see that okay? Alright, that didn't help much. Let's see if I can get it. Yeah, let's see if that works. Alright, you can see it a little better. If I have those numbers in there, which don't have anything to do with my list, and I want to get them out of list 1, I could go up, scroll up to where it says L1, and just hit clear and enter. Do not hit delete, otherwise you deleted the list. L1 will no longer exist in that list. You'll have to go get it back by doing a bunch of other stuff. Okay? So, we're going to enter all the data. So right now, let's go ahead and enter 58, 75. So just 58, enter. 75, enter. 60, enter. Make sure you're double checking after you enter them. Otherwise, you're going to get the wrong answer. What? No, doesn't matter. I'm just putting them in the order I see them. Okay, so 58, 75, 60, 48, 56, 78, 60, 57, 54, 59. Okay. Notice on down here it tells me how many I have. It says L1 10. That 10 means that's the 10th entry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. If it says L1 11, then you entered a number too many times. Okay? After you get them entered, you go second mode. What is second mode? It is quit. Okay, notice when you push the second key, it activates everything in that color. So when I push second, it activates the quit above mode. So if I put mode, it quits. Brings you back to the home screen. Some people don't. Okay? And then from there, you're going to calculate your standard deviation. So you need to push stat again. That's why you're writing it down, because if you don't, I'm not going to remind you again. Okay? Stat. We're going to arrow over 1 to the right and select calculate or calc. And you're calculating option number 1, which is 1 bar stats. You're using 1 bar stats because you have one variable you're dealing with. 1 bar stats. And then you push, after you've selected that, you push enter 3 times. Or until you actually get a bunch of things to appear. And you now have your information you need. Okay? Let's take a look at this information. First, everyone there?
On the test, are we going to be able to
Yes. You can use your calculator on your test.
No, like, are we able to put this on or no?
Oh, I'm not sure. Good question. We'll talk about it. Hopefully you'll start memorizing. Okay? Hey, what does X bar mean?
Mean.
X bar is mean, so it tells you the mean. Right? You guys know how to read this stuff because you know how to read the math. X bar is mean. This little symbol right here, that backwards looking E, means the sum of X. That means if I added all those things up, the sum is 605. This is capital sigma. If you want to know what these things mean, then write them down. That means the sum of the data was 605. This right here means the sum of the data squared. So if I took 605 and squared it, I get that. Or excuse me, not 605 squared. If I squared the pieces of my data and added them up. Excuse me. It's not the square of the sum. It's the square of the pieces of the data and then added together. The square of the pieces of data. These you really don't, you don't necessarily need to know what those mean. The big one that, yes, Sarah. Okay, you're going to have to, we're following these. For now, maybe follow along with one of your classmates there. Okay? You guys all, do none of you have it? You have it. You don't have it. Okay. I'll have to come over and help you guys. Right now, you're just following along with me. Okay? This right here, the sum of X, or excuse me, not the sum of X. This is a different version of standard deviation. The one that we want is this one right here. That is the standard deviation. Remember the symbol for standard deviation is sigma, the lowercase. So the standard deviation to the nearest hundredth on here, is that what it asks for? It doesn't even ask. So let's go the nearest tenth, is 8.7. So find the standard deviation. It's 8.7. What does that mean? Well, here's what standard deviation means. You know what it means? Take a guess.
It's kind of like average, but it's like guessing how much it goes up by each time.
It has to do with the average. You guys, standard deviation. Cassie, you know what it means? You're telling them? Oh, you don't? Okay. Standard deviation. It means that's how much in the context of this problem is how much the typical height deviates from the mean. Okay? Yeah. So it means the typical height, since we're dealing with height of basketball players here, the typical height differs from the mean by 8.7 inches. Okay, so we know the mean based on our data was 60.5. The typical height would differ by 8.7 inches. So a person that's one standard deviation away would either be at 68.7 inches or 60.5 plus 8.7 or 60.5 minus 8.7. That would be one standard deviation away. Okay? I'm not going to do part B and C right now, but this is how you enter it into your calculator. Okay? Why don't you take a look at number 5. All right, last piece. Find the values of the measures shown when each value of the data set is increased by 8. So I want you to go back to your previous page. See how increasing by adding a value every time, since we're increasing by 8, we're adding a value. Tell how it's going to affect each of those things.
Stop talking.
Just stop.
You should be happy that those people have enough courage to get up there.
Yeah. I couldn't do it. Okay? Hey.
Well, that's you.
Hey, when we add when we add numbers to our mean or to our set of data, does the mean change? Yes? Yeah, when we're adding to the values, I don't have that page anymore. When we're adding to that value, the mean increases by 8.
Wait.
Does the median change? Yes, the median changes. It increases by 8. Does the mode change? Yes, the mode changes. The mode increases by 8. All measures of center increase by 8. These are your measures of center. Remember, when we're adding, everything increases by the amount you're adding for the measure of center. I'll get to you in a minute. Does your range change? Range does not change. The standard deviation change.
No.
No change for measures of, what are these called?
Center. Wait, no. Wait, yes.
Thank you. Measures of variation. When adding. When will the measures of variation change? When multiplying. Good. All right.